guidance build and result in very large modifications to neural network model weights during training. This is known as exploding gradients. Gradients are utilized to update network weights during training. Although this process works best when the updates are minimal and controlled, when the magnitudes of the guidance add up, an unstable network is likely to form, resulting in poor prediction results, or possibly a model that reports nothing meaningful at all. So, exploding guidance can cause issues with artificial neural network trainings. So, the guidance problems will get issue with the artificial network training. When the guidance explode, an unusual network can form and learning cannot be completed. So we need to be careful with the guidance. So the weights values can also become so enormous that they overflow, resulting in non-values. So when the overflows occurs, then it results with the non-values. So we need to be careful with this. So we should not get any guidance problems. Now we can see the limitations of simple RNN networks. The vanish or exploit guidance problems. An unfolding RNN is trained in many time steps with the error guidance calculated as the sum of all guidance error occur time slabs. As a result, the algorithm is frequently referred to a back propaganda over time. Because the chain rule is used to calculate the error guidance, the dominance of the multiplication term increases over time, causing the guidance to burst or vanish. The guidance will appear if the biggest even value is smaller than 1. The guidance explodes with the biggest even value is greater than 1. It won't go to till 1, it will be the down. When the chain rule is used to calculate the error guidance, the domination of multiplication term increases over time. So when it takes the over time, the guidance to burst or vanish, the guidance will disappear if the biggest value is smaller than 1. So it should be like bigger, otherwise it will be disappear. Slow and complex training procedures. The premier disadvantage of RNN is that they are recurring, that is, they will require a specified amount of time for training when compared to feed-forward networks. The overall training speed of RNN is rather slow. Second one, RNN is challenging to construct since it requires calibrating parallel outputs as well as current input into a state change function per node. The complexity of training can make it difficult to modify RNN training. So like when the major primary disadvantage of RNN is that they're recording the significant amount of time for training when compared to the before networks. So it may cause for the training procedures. So the complexity of the training can make it difficult to modify RNN training. So we should not make that much time to get the RNN training. RNNs can't be stacked up. Another issue with parallelized RNN training are a simple track up of training is due to essential feature of RNN, which is that they are collected. This means that RNN need the output of the procedure not to compute over the current node. RNN are not ideal for parallelizing or stacking with other modules because of the relationship. The overall computing expenses will never be justified by any accuracy improvement. So the another issue for RNN is to parallelize the training or the stacking simple training. When they are connected, we should not like parallelize. That means that RNN need to be output of the procedure nodes. So like LSTMs overcomes the vanish guidance problem by adopting a distinct adaptive gradient structure that includes direct access to the activation of the forgot gate, allowing the network to encourage desired behavior from the error guidance via frequent gate updates at each time step of the learning procedure. By carefully setting the network model, such as utilizing a minimal learning rate, scaling the target variable, and using a standard loss function, exploiting guidance can be avoided. However, exploiting guidance may still be a concern in recurrent networks with a large number of input time steps. Like we need to overcome with these all by carefully setting up the network model, such as utilizing a minimum learning rate, scaling the target variables, and using a standard low function. So we can exploit guidance for the recurrent networks. It is difficult to train RNN, demands long-term normalization, whereas LSTM performs better in these type of datasets since it includes more additional special units that can keep information for a long period of time. The LSTM contains a memory cell that can store information for lengthy period of time. So it's difficult to train RNN demands long-term mobilization because it contains a memory cell that can store more information for a long period of time. We can see the graph like the input layer, LSTM layer, dropout load. Which is having like the long memorizable should be minimum learning rate and scaling the target variable and using standard low function. Exploiting guidance could be avoided. So we need to be careful with the scaling and the loss functions. Dropout layers, dense layer. Summary of core parameters, percentage of data testing. Like we said, the data setting should be like 0.1. Layer of LSTM, it has one input layer, two dropout layer, and third one is LSTM layer, one dense layer. Number of layers in each LSTM layer. First LSTM layer has 64 neurons. Second LSTM layer and third LSTM layer has 50 each neurons. LSTM layers and dropout layers. Input one. Like we said here, like we have one input layer, two dropout layers. This one is one input layer and two dropout layers and three LSTMs. And it has third LSTM layer has 50 neural networks. Dropout layer, two dropout layers. The percentage to drop is 0.2. These are the two dropout layers. The percentage should be like 0.2. The length of the time series input sequence is 50. Time sequence should be 50. Batch size for training is 64. Number of approaches for training is 5. Number of approaches should be 5. And the batch size for training is 64. Result first and foremost, we must Import liberties visualization is achieved with the help of